The previous video showed how to create a new data model in Tableau's Alpha and how it will automatically aggregate your measures to the right level of detail, and then finally how it will display full domains of dimensions without you having to specify that through joins. So this video is going to focus on some major changes to the schema viewer and how that impacts calculations. All right, so in previous or existing Tableau, your data is divided in the schema viewer between dimensions and measures. With the new data model, we're changing that so that it's grouped by object, which we think is a more natural way that people think about their data. So it's grouping all fields within donations, and then inside of the donations, it splits your fields into dimensions and measures. So this is a huge change, and it's one that we're very keen to get your feedback on. So please let us know if you like this or if you don't like this, and either way, why. Now, another impact is calculation authoring. So what happens if we create, where do new calculations go in this new world? So this is best illustrated with an example. Now you'll notice in the donors object we have a donor state, and then in the schools object we have a school state. And so it's possible, for example, that a donor from New York makes a donation to a school in Washington. And it may be interesting to analyze what percentage of donations are coming from out of state. So we can easily compute that by comparing the donor state to the school state in a Boolean calculation. So we'll just come here and write that donor state is equal to the school state, and this gives us in-state donations. And so now the question is, well, where is this thing going to go? It's not describing donors, and it's not describing states, even though both of those things are being referenced. It's actually describing donations, and so this should go in the donations object. Now, if you come to the graph, you'll see that schools and donors are connected to each other via projects, via donations. And so donations is the lowest point in the tree or in the graph where these first connect to each other. And so that's how it's going to know to put this in the donations object. If we created a calculation, for example, that referenced schools and teachers, then because the first point where they can speak to each other is projects, those calculations would appear in the projects object. So just to illustrate, as a point of illustration here, if I now go hit apply, you'll see that this has just appeared inside of the donations object within the schema viewer. And so from there, we can do things like count the donation numbers and then split that by in-state donations. It's also worth pointing out at this point we haven't yet implemented number of records. So if you're looking for that field, it doesn't yet exist. In the website, if you find the appropriate section, there's a described workaround for how to achieve that until we build it. All right, so then, yeah, because this is working with Tableau, oops, I meant to do a percent of total. So because this is now fully integrated inside of Tableau, you can still use table calculations, for example, on top of results that are determined using the new data model. And so here we see that 33% of donations come from out of state, which is interesting. Okay, so that shows like what happens with row level calculations. Now, another question is what happens with aggregate calculations? So if we come back to this view that shows your project cost by school, I may actually want to compare the project cost to the donation amount and then see what percent of their required funding have they achieved. So let's bring in the donation amount, and then let's go and calculate that as a percent of the project cost. So we'll just divide the donation amount by the project cost. And note that we're creating a ratio across two tables that are at different levels of detail, but because of the smart semantics in the new data model, it automatically knows how to resolve that. So now we've got that as an aggregate calculation. So let's see what happens when we bring this into the schema viewer. And this is going to be our percent attained. And note that it didn't put it inside of an object anywhere. Because it's an aggregate calculation, and so the level of detail is determined on the fly on a case-by-case basis in your worksheet based on whatever you drag and drop here. And so it doesn't actually map to any object. It's just like a definition of how to compute this calculation versus tying it to a particular object. Now, to give you an example, a kind of concrete example about like when would you not want to have an aggregate calculation? Well, one thing you might want to do rather than just kind of report on the percentage attained across these 2,300 schools, or sorry, no, 821 schools, is say like what number of schools have achieved between 0 to 5% of their target? How many schools have achieved between 5 and 10% of their target? And so in that case, you have to actually group the schools based on their percentage attained, which requires making this thing belong to the school's object. And so we can do that using a level of detail expression. So let me go and modify this and say, or just rather fix this to the school ID from the school's object. So let me just drag this in here. And let's see, so this is now percent attained by school. It's no longer just this like generic definition of a calculation. So when I hit apply on this, note that that thing now appears inside of the school object. Now, one thing I want to be clear about is that while object model removes the requirement to write level of detail expressions for the purpose of modifying your data model, it does not remove the requirement for LOD expressions in general. And they're still a very useful analytical tool for examples such as this one. Okay, so now just note something interesting. If I go to this aggregate one and try and create bins, I can't because bins require grouping a thing and you cannot group a definition. Whereas if I go and try to create bins on this one that belongs to the school's object, then it does allow me to do that. And so we can then use that to count the number of schools that fall into each bin. Now, I'm going to just pause and make a point here that's also super interesting, is that note that count of school ID and count distinct school ID give exactly the same result. Now, count distincts are notoriously very expensive operation, and if you have very slow dashboards and there's loads of count distincts, that's probably one of the reasons why. But now, because Tableau's data model is able to keep every object at its kind of correct level of detail, you can use counts instead of count distincts, and that will give you potentially some huge performance benefits. So now we can go and divide our number of schools by our percent attained, and so this is telling you that 66 schools have achieved between 0 to 5% of their required donation amount. And then there's 700 nulls. Now there's this temptation, like when you see a null, to just think, oh, it's garbage data, let me exclude that. But that's actually not true. Like, nulls are really interesting. When things don't match, it actually, it can actually have some meaningful information about the data. So consider the following. You can have schools that have projects, but the projects don't have donations. So that means that, you know, some student out there is trying to like fundraise for something and no one's giving them any money. That's sad. Whereas you could also have schools that don't have projects, and in that case they just haven't, they're not even trying to raise any money. So those are two very different scenarios. Whereas at the moment, the null is grouping those two things as like one. So let me go back and see why. And it's doing that because I told it to do that. So specifically it's because this percent attained, actually I should be looking at that one instead, is taking the sum of donation amount, which is null in the case where the person did not make a donation. But now, because of clever join semantics, we can actually say, well, replace those things that didn't happen with, treat them as nulls and then replace it with 0 by adding this ZN around here. And so now when I hit apply, that has dropped from 700 to 646, and those 54 schools have now appeared in this object here. And so now it's saying that, this is giving you something, a different story, which is saying that there's 54 schools that don't have any donations at all. Whereas this 646 number here corresponds to schools that simply don't have projects. And so at that point, I may be interested in excluding those. Now, one kind of point I really want to bring home here is that you would typically be expressing these concepts through joins, through left joins or right joins, whereas now we're bringing a lot of those, we're deferring a lot of those decisions from the modeling time into analysis time, which makes it a lot more flexible and also a lot more intuitive. So I'm going to stop at this point. I could go on forever, but I want you guys to have a chance to test this out and let us know your feedback. There's just going to be one more video after this, which is going to be on how migration works for workbooks that were created in previous versions.